Okay, so I forgot to add some pages and it doesn't like it when I add it mid-work, so better do that. So I am solving a 3-variable equation, which means I need 3 equations. So how many ever variables you need that many equations to be able to solve it. When we do this, I usually start by labeling them 1, 2, and 3. And this is simply so that I can keep track of what I'm doing, because my goal is to take my 3 equations and turn them into equations 4 and 5 that I can then solve as a normal 2-variable equation. So I have to first decide which variable I'm going to eliminate. And like if I look at z, I'm like, oh, well, there's a 5 and a 2. Both x and y to me look better than z. But I really like y because I can see that 1 and 2, I don't have to do any work. They're going to cancel out naturally. I like anything that saves me effort. So I'm going to start with equations 1 and 2. And I'm going to turn them into equation 4, okay? And so I can just write them down as is because I don't even need to change anything. And I get, let's see here, negative 3x plus z equals negative 8. So this is equation 4, okay? And somehow mark them very clearly on your paper, start another pile somewhere else, because you're going to want to come back to these, and so you want to make sure you have them well marked, okay? Now I'm going to do the same thing again, but I need to make equation 4. Here's the catch, though. I have to eliminate y again. Don't get excited and eliminate x. Won't do you any good. I need to eliminate y because I want a 2-variable equation now in x and z, because that's what I've started. So once I commit to I'm eliminating y, I have to stick with y. Okay? Made a commitment, got to follow it through. So when I look at this, I just used 1 and 2. I'm not going to do that again. So I can either use 2 and 3 or 1 and 3. I'm going to use 1 and 3. The reason I'm going to use 1 and 3 is they're already opposite sides. And in general, I'm for anything that lets me not have to change sign. So equations 1 and 3, okay? Yeah. So equation 1, I can see here, I need to start my y. So I'm going to leave equation 3 as is. Okay, so I'm going to take that down. 2x minus 2y minus 5z equals 7. And then this top one, I need to times by 2, right? So that I can line up those. So I'm going to get 2x plus 2y minus 2z equals negative 2. So now I'm going to add these, and I get 4x minus 7z equals 5. So this is equation 5. So now I have my 2-variable system. So I'm going to write down my 2-variable system. 4x minus 7z equals 5. And then I had negative 3x plus z equals negative 8. Okay, this is now a 2-variable system in terms of z. So I now have the option, I want to solve this. I can use elimination or I can use substitution. Now, just to be different, I'm going to use substitution. Either one will work because I can see this can be really easily solved for z. So I'm going to rewrite this. Z equals 3x minus 8. So I'm going to take this, plug this in for z. 4x minus 7 times 3x minus 8 equals 5. Okay, so equals 5. So I get 4x minus 21x plus 56 equals 5. So then I have negative 17x, 4 minus 21. And then I'm going to move this over here. So that's negative 51. So x is 3. Okay. And if you obviously didn't know 51 divided by 17, the two negatives cancel out, is 3. You could do that on your calculator. Now I need to start working backwards. So taking this x and putting it back into our original equations doesn't do us any good. Instead, I want to put it into this one because this will allow me to solve for z. And I've already got this even solved for z. So might as well use what I've got. So this is 9 minus 8, which is 1. So now I have both z and x. So now that I have two variables solved for, I'm going to go all the way back to one of my original equations. So and I like that first one. It's nice and easy. So x plus y minus z equals negative 1. So let's see if I can remember that by the time I get down here. So x plus y minus z equals negative 1. Pretty sure I wrote that down right. But I'm going to go back up and double check. And again, this is why it's much easier not to do it when you're going back and forth up the top. Yeah, it's 2 minuses. Now I'm going to plug in what I know. So I have this and this. So I have 3 plus y minus 1 equals negative 1. So this is 2 plus y equals negative 1 minus a 2 minus a 2. Y equals negative 3. So then my final solution here is 3, negative 3, 1, x, y, and z. These are long. That is easy to get lost in the middle. So you need to focus on that. I'm starting by taking my 3 and I'm creating 2 new equations out of them, 4 and 5, that are going to be in 2 variables. Then I can solve by my normal methods. Once I have one, then it's a matter of just working your way backwards until you find all 3. So after you find that first one, you're going to go back to that 2 variable system, solve for the other one. Then once you have those 2, you go back to one of your original equations and plug it in to find your third variable.